All right, welcome everybody. Today, I want to talk to you about classification model when there are more than two categories. Okay, so to that effect, I am putting here what is called multinomial logistic model, which is, it's called multinomial logit. Usually when all the variables are qualitative in nature, certain groups of practitioners call it as logit. And if it is a mixture of qualitative and continuous variable, some people call it as multinomial logistic model. Okay, so that's what we want to talk about. And I want to explain it to you and how to use it, how to interpret it. Also, I will give you some instructions on how to run other than multinomial logistic model, for example, Poisson regression model, which is about count variables. The outcomes are 1, 2, 0, 1, 2, 3, like that. Okay. Oftentimes, that is another model, another type of model you will be required to build. So with this collection of tools, you should be able to do both classification and regression for a wide class of models. Okay, wide class models. It's not everything, but in your practice as a starting analyst, you will be fine, be good. So that is my purpose today. I want to stop here and ask you if you have any questions so far in the class that bothers you, that I can spend more time, or make you feel confident and comfortable. Go ahead, please. Can you talk to me?
As of now, there is no doubt, sir. But if we have any hands-on experience, then we'll have lots of doubts. So at that time, we'll be asking doubts, sir.
Okay. When you have hands-on, what do you mean? When you have hands-on means when you work in the job?
No. Like any real-time scenarios.
How that real-time scenario is going to come? I'm wondering where. Okay. So I have been giving instructions, right? Teaching. Then you will also go through practical sessions. Maybe you are talking about practical sessions.
Yes, sir. Okay. Exactly. Right.
That's fine. That's fine. So we have to start practical sessions. Pretty much we'll start, now. I'm kind of waiting for someone to come in. And, she has, people are, I think her mother and also father-in-law passed away. So she took time off. She will be joining us. Supriya, you might have heard of her name. She is very good, and once she joins, and you will be going through the lab sessions like this regularly. Okay, but hopefully, it will all be over soon, before the end of the month, or maybe it will extend, but that's okay. She will continuously do both PA1, PA2, PA1 and PA2, as well as machine learning. Okay, AI. So yeah, okay, I understand. Perhaps at that time you have questions. That's fine. But I do want to keep questioning this. You have to go through these ideas of what is it, why it is done this way, things like that. All kinds of questions which will aid you to become more comfortable. Are you with me? You know what I'm saying? So I'm sorry. So far, we have done a lot of concepts, a lot of definitions, a lot of critical thinking. Can each of you give me 5 points, each of you? I'm going to write it down. Is my question clear to you? So far, I have done 12, 14 hours. 12. How many hours I did so far? Go ahead, Shali.
15 hours, sir.
Almost, almost done 15 hours. But this will be our last class together, okay? There is so much to do. I was thinking that I should do this. Very important. Extension to multinomial logistic model, okay? So 10, each of you can give me what 5 things it essentially captures the most important things in this class that you have learned so far. You should be able to articulate that. Do you agree with me? You can go back and review your notes if you're taking notes. Are you with me? I want to see your faces. Everybody is showing up your face. APSP. Go ahead. I can't hear you, Abhi. You're probably saying something. Anto?
No, I'm looking into my notes, sir.
Sorry?
I'm looking into my notes, sir.
Okay, go ahead. Anto, go ahead now.
I think. Am I audible?
You are audible. Wish it can be more loud.
Yes, you are audible.
Okay, go
Is
ahead.
it fine now?
That's okay.
Fine?
Go ahead.
The first thing would be, sir, the linear regression, how we are learning to fit in a line, fit in a function to the different data points we have.
Good. Fit a linear model. Let's call that way. Okay, linear model. Okay.
Yeah.
Okay, for
A
prediction
linear model,
purposes.
in general, any function. For the linear regression, a linear model. That is
Yeah, linear regression you can say sometimes people say linear model. Linear regression is fine. We know how to, you are saying you know how to fit a linear regression model. Okay.
Yes, sir.
Excellent point. Keep going quickly. 5. Because I want Abhi to have 5 chances. Go ahead.
And then the various diagnostics we did in that.
Excellent. Next. Go ahead. 3 more.
Yes, sir. And then the hat matrix part, the weight matrix part.
Yeah, hat matrix or weight matrix. Okay, good.
If we have n number of variables, then
Yes.
solving equations would be difficult.
Yes.
Rather, we had found an alternative method.
Yes. Excellent. Next. Abhi, are you getting ready?
And the inner sum one.
Huh?
The inner sum, which she had mentioned explicitly, the product sum in Excel.
Product sum.
We had used it.
This?
The product sum was for the logistic regression.
Product sum for
When we were,
but we use the product sum even in linear regression, but that's okay. Logistic regression. So you mean you're talking about maximum likelihood method. For maximum likelihood method, and also odds ratio is a linear function in logistic, right?
yes, sir.
Maximum likelihood
And
method as well as odds ratio is essentially, even though it looks very complicated, odds ratio is a linear function in logistic model, right? Linear expression in logistic model, right? That's what I think you said everything. 5 points, right? I think you said 5 points. Go
One
ahead.
more thing is the influential point.
Excellent.
The most crucial
Yes.
point and Cook's distance.
Yes, influential points. And how do you figure that out? Using Cook's distance.
Yes. Yes, sir.
Excellent. Next.
And the variance and the bias.
Oh, super. Variance.
I was taught in the last class.
No, yes, 1 second. Variance, bias variance, that's a combination.
Yes.
Okay? Bias variance trade-off.
Yes,
Okay. But do you know what is the purpose of that? We'll come to that.
To find the accuracy, like yes, to find out the accuracy of our model.
To find the best
By
model.
changing the variance, we find it. We find the accuracy.
No, find the best model.
By changing the variance.
You have to say to find the best model. Okay?
Yeah, best.
Yeah.
Yes, sir.
Vice versa instead of next. Next, Abhi, go ahead.
Next, the likelihood function,
Okay.
log of odds.
Log of odds and likelihood function. Excellent. One more.
Yes, sir.
Please, one more.
A receiver operating call, a
Oh,
rock.
super. Receiver operating curve. Yes. And then AU rock, right? Area under the curve.
Yes. Yes,
Model
sir.
selection using profit and deciles. Model selection using deciling approach, right?
Yes, sir.
Model selection using deciling approach, right? Okay. These are great, and all these points are wonderful points. You guys get one more. If you do want to say anything else,
So I have one doubt.
go ahead.
Sir,
Abhi, keep looking. Go ahead,
Yes, sir.
Anto.
yes, sir. So to remove the outliers and the influential data points, I was going through some other method using the box plots. So apart from the Cook's distance method,
Single variable model. I mean, not model, single variable analysis.
Yes.
Univariate analysis. Okay, correct.
So can we do that? Like considering Cook's distance as well?
No. Okay, here is what is going on, right? If you are looking at a single variable analysis, box plot is what you want. Okay, especially as exploratory analysis. Okay, but what we are saying, Cook's distance is about influential observation where there are relationships between variables. One variable is dependent on another variable. In the case of relationships, associations, especially relationships, I don't want to bring it down to association. More importantly, it is about the linear relationship
In independent variables.
between two variables or between n variables, where we have a model y as a function of alpha plus beta 1 x1 plus beta 2 x2 plus beta 3 x3, like that, right? The linear regression model. In the case of linear regression model, you can use Cook's distance. In fact, in the case of the logistic regression models also, I gave you Cook's distance. If you remember, I gave you diagnostics analysis in the case of logistic regression model also. Do you remember that, Abhi?
In logistic regression?
Even in logistic regression, I have shown you something like this. Let me see. Not this one. Even in logistic regression, I was walking you through that. Here it is. Is this one?
Yes, sir.
Yeah. So we use two types of residuals: deviance residual, Pearson residual, raw residual. Actually, three types. And then I said there is a command which you can use to get these residual analysis. See, this is the final one. The Cook's distance leverage versus the studentized Pearson residual or standardized Pearson residual gives you the ability to detect any unusual points that are distorting the model, right? So these boundaries are giving you that the Cook's distance boundaries here. So anything outside of this, falling beyond this or below this is influential point. So we did review that also, but it's most commonly it's much easier for not much easier. The observations effect are clearly greatly influencing linear regression models than in the case of logistic regression model, because the logistic regression model is within a two bands only. Okay, either it's here or it's here, right? And it is connecting like this. Do you see me what I'm saying? My hand, it's going like this, right? Do you remember that? So the logistic regression model is like this. They're all pretty quiet. Why is that? Do you remember this? This is the logistic regression model. This orange or yellow curve, right? Orange or yellow curve. Are you with me?
Yes, sir.
Yeah. So,
Yes.
So you have diagnostics even in the logistic regression model also. Okay, Bhabhi?
So,
All right. Anything else? Oh, did I answer your question, Anto?
Yes, sir.
Okay. Bhabhi, go ahead. Do you want to say anything else? I think almost, pretty much you guys have captured all the essential things. Okay? All these things. Do you feel comfortable explaining these things, even with the notes? Do you think you'll be able to explain?
yes,
What about
sir.
the notes?
But with notes.
With notes. Without notes, you can do it also. But with the notes, it's great. Whatever I have given. Is that good?
Yes, sir.
Okay. When you say yes, I want to see you. When you say yes, Anto, I want to see you. That's a joyful time. All right. Goshali, how is it going?
So
Okay.
for me, it's fine, sir.
Oh, good.
So it is recollecting everything.
Recollecting. Very good. Very good. All right. So
Yes.
these are essentially the points, that, you have learned. And of course, we have more 15 hours, almost 15 hours. You'll get to the lab hours also. You should be fine. Okay. This course has been taught so many times. It's, standardized to a level. You will feel comfortable and you will feel the mastery. Okay. Now, Anto, how do you feel so far?
Yes, I'm understood, but I still have to practice a lot,
of course,
so that I can.
Of course, I agree with you. Okay. All right. So today, let me finish this multinomial logistic model, because this is another case we want to do. You will end up doing it. So here, this is the Princeton notes I want to share with you. Please take note of this. I'm going to put it in the chat area. All right. Keep it in your reference. Put it in your notebook, or your Word, PowerPoint deck. So in this case, it's about Harvard Business School. They get people into their system, right, for study, for the management program. So they had this data set for them, for the students, the socioeconomic status. How is it related to science, social status, and the gender. Okay, that's what they were using. These are the independent variables. Everybody understands? Okay, are you able to see what I'm saying, showing?
Yes, sir.
Okay, so the data is something called my data. I downloaded the data. I can give you the data for you to practice. So maybe it will be shown to you in the lab time. Okay, that is a good time to show. Let me give you the essentials of the multinomial. That means multiple class models. Please note it down very clear, right? Multiple class models. So there is a package called Stargazer. Okay, that's what we are going to use. And that function has that has what is called a multinom, a function called multinom. All right, and that multinom, yeah, we are using it for the data HBS, that is Harvard Business School data. And what we are trying to predict is economic status on the basis of whether they are science graduates, or and what is the social status they have, and then what gender they have. So the female is in comparison with males, and so these are the variables, and the socioeconomic status is the dependent variable. So we have here. Let me see. There is also lending club data. We do that. We do that in the during lab hours. Okay, lending club data. So I want to look into that. One second. I downloaded the data. Let me see whether I can show it to you here. That it should be here. Where is it? Give me a moment, please. So you can add this also to your list of things. Let me see. Okay. All right. This is another data set. This is MBA starting salaries. Not this one. Social economic status.
So, sir, which data sets you're looking for? Sir?
It's about a Harvard Business Review. Harvard Business School. Harvard Business School.
I'll check, sir, whether we have. So, in our group,
Yeah, I don't think we have the data. Let me. Okay, here it is. No, this is not multinomial logistic. They say multinomial logistic. Okay, we can do the multinomial logistic also using the Titanic dataset. You all know the Titanic dataset, right? You remember that, everybody? Titanic dataset, we did that. So in the case of Titanic dataset, we want to predict who is likely to be embarking from. Okay, who is likely to be? Is that embarking from? No, what class you are likely to belong to? Okay, what class you are likely to belong on? Okay, yes, the embarkation, gender, class. So the model we are going to build is multinomial formula. Yes. So in the case of the Titanic data set, there are variables we know. We saw that, right? Gender of the passenger, where they boarded the ship, embarkment, where they boarded the ship, sibling, do they have somebody has a sibling or not, and then this is its accompaniment. Okay, parchment is no. I gave you a PPT? Remember that, everybody? I gave you a PPT, right? About
Yes, sir.
yeah. In that one, there is also the definition of parch. Okay? So what we want to predict is, we convert the problem not as a survival, who is likely to belong to a particular class in the ship. Okay. Is it, is gender influencing that? Where they come from, is it influencing that? Sibling, if they have a sibling, does it influence that, or the variable parts? Okay. So basically, there is a package called NNET. Okay, NNET, it's really a neural network package, but they have a function to do multinom, a function called multinom that can help you to do multinomial logistic model. Everybody's good? Multiple class model, because PC class are 3 classes. You remember that, and that's what the tabulation here says. Data set D1 is the data set, data frame, and we are just checking what are the classes in the passenger class. That is class 1, 2, 3. There are 214 people in class 1, 184 people in class 2, and 491 people in class 3. And first class and second class have higher priority of escaping because they are closer to the floating and the small boats. Okay, in times of drowning, the small boats are used as well as the floaters. Okay, that you can bear it and then jump into the shape the small boats, and then you have a better way of escaping it. Right. That was about the problem of survival. But now, who is likely to be in class 1, class 2, class 3? That is the problem we are trying to solve. Is everybody clear? In the case of Titanic dataset, which you can do for any other dataset also, but we are going to show it as an example for the case of multinomial logistic model. Is everybody good?
Yes, sir.
So the
Yes,
model is, we call it as, this is the formula. We always use this like this, right? The formula is the formula is quoted here. You don't need to write in 2 sentences. You can just put it like this. Okay, put it here in the case of multinom, and then run this model. So so that is what is done here. So multinom is the function you have to use. Just remember that it is not GLM, it is multinom, and you have to use the library NNET. So you use that expression that predict P class, the passenger class, using these variables. Okay, only. So when we do that, this is the output you get. Okay, the output is stored into the output. The model is this. MOD is the model. That's the object. Okay, and that object you can summarize that object. That's what it is. You don't have to do all these things. Now there's too many commands we use here. We just have to put multinom. Okay, multinom, and then the summation formula that we use here, and then the data. So here is interesting thing. So there are 3 classes, and then there is no set of parameters. Remember, the parameter values are given in this way. Is everybody good what I'm talking? So there are actually 2 models here. There are 3 classes, there are 2 models here. Listen very carefully. 1 versus 2 is this model. The one passenger class 1 versus this is the 1 model. The other one is 1 versus 3, that is this model. This whole thing is about estimates of these parameters. The sex is male is the reference class. The male is the predicted class. The reference class is in the intercept. Okay, embarked Q. Embarked Q. So what are the different embarkment areas? There are 3 embarkment areas, right? Q, S, and another class. Can we go back to that? Maybe that we should look at the data set to feel a little bit more comfortable. Okay, let me go back to the here. Let me see. Okay, I'm not seeing it here. Let me open it. Even I can't see it. So just hang in there. Okay, don't worry about it. No, not this. I didn't mean this. Let me open file. Okay, it's here. That's very good. Okay. So here is the PowerPoint deck I was talking about. Let me first, I should have done that. Okay, it did figure it out. It did figure out how to do it. Okay, good. So, did you take a look at this one presentation deck, everybody? So, what I want to tell you is that these are the variable data dictionary, right? PC class, class 1, first class, 2 means second class, 3 means second class, third class. Survival means 0 means no, not survived. 1 means yes. 6 means gender, basically age in years. Siblings, spouses aboard the Titanic porch. Parents, that's what it means. Parent child is porch. Okay, parent child is porch. Okay, whether it has a the person is accompanied by a parent or not, that's what porch variable is. Okay, so and then ticket number, fare, passenger, how much fare they paid, and then the cabin number. Embarkation is this one. C means Cherbourg, Q means Queenstown, S means Southampton. That's what I was trying to recall. Okay. So when we say that the passenger class means one means upper class, 2 means middle class, 3 means lower class. Okay. So it's a kind of reference to the socioeconomic status. So the porch variable, the parent-child relationship variable, whether it tells you whether it's mother, does the person have a mother or father with them, parent, with the parent, child, daughter. One second. Okay. Child refers to daughter, son, stepdaughter. It could be stepson, and so on. Some children travel only with a nanny. Therefore, porch variable is 0. Okay. So those are the variable definitions. Everybody understands this, right? I mean, I gave this only for you to go over this because the story is built here with a lot more details. Okay, a lot more information. That's why I gave you this one. Is everybody good? What I'm talking about? So going back to this, going back to this, I'm explaining all these things. Go ahead, Abhi. Are you able to go ahead? You want to say something? I thought I heard some voice. Okay, no problem. So that in this data set, we are trying to predict the socioeconomic status through the passenger class. That is our purpose. Socioeconomic status through passenger class. Now, let me go back to that presentation, right? Yeah. So not this one, P class, right? Remember? Passenger class. We were trying to do passenger class. This is not this one. We were looking at the outputs. Yeah. So the passenger class, I want your attention here. Explain to me, does it make sense to you? Because what I'm saying is, in a multinomial class, there are 3 classes. So, the passenger class, high class, middle class, low class, right? I mean, socially they are well off, moderately well off, probably, just barely scratching money to come to USA. So what we are saying, the first class is compared with because binomial regression is what we taught you, right? What I have taught you, binomial regression, that means 2-class model is what I taught. So all the definition about logistic regression, the details I gave you, a lot of details I explained, all those things, is all about 2-class model. So what does that mean to say multinomial model? So let me explain one more time. In the case of multinomial model, you are always comparing. Look at this one. If you have 3 classes, right? J equal to 2, it starts from 2, 3, 4, 5, if I have 10 classes, it will go up to 10. So listen very carefully, 2, 3, 4, 5 to go, right? So we have three class situation. So it will stop with 2 and 3. Do you agree with me? And what we are saying is that logit is same as logistic. Remember that, okay? But because of qualitative variable, some people call it as logit. So logit of the second class probability is log odds of the second class probability with respect to the first class probability. Please note this very carefully, what I'm saying. And it is a regression, linear expression. Agreed so far? Anto?
Yes, sir.
Super.
Yes, sir.
Anto?
Yes, sir.
Okay, cool. So this is for the second class. Now for the third class, I will have, and it will stop with third class. This is for general, right, up to G classes. Third class will be logit pi probability of the third class predicted equation is logarithm of odds of the third class probability pi j, which is basically the probability of the third class, divided by probability of the first class, is a linear function. So that's why you get two estimates of the betas, beta 1 vector and beta 2 vector. Well, beta 2 vector and beta 3 vector. Okay, three class, beta 2 vector and beta 3 vector. Everybody is good so far? So this is coming from this expression. If you remember, we had similar expression for the binomial class, isn't it? So pi 1, that is p1 instead of pi 1. There it is p1, p0. Here it is pi 1, which is instead of P1, I'm saying pi 1. So people use different notation. But the point is, you can see this is same as logistic expression in the case of the binomial model, two class model. And it's also same kind of expression in the case of two class model. But then there are three classes. So pi 1 is like this, pi 2 is like this, pi 3 is like this. The only thing is J changes. So that's why you get three classes, two models. Do you agree? Because this is the reference class. In the case of in the place of two class model, you got one model. Agreed? One vector of parameters. Got it?
Yes, sir.
Yes, sir.
Good. Thank you so much. Because that critical jump, once you understand, everything else will be clear. So this is just about data manipulation, data wrangling. We did that. Okay, don't worry about it. You did that. So there's a lot of data wrangling, and then this is just looking at the data frame. Okay, data frame. So he is just saying, I want to take a look at the first 10 rows of the data for these columns only. This is just an arc line. Agreed? So first observation is, third class, it's a male, from Southampton, sibling. Did he have a sibling? Yes. Is he accompanied by parents? No. That's what this means. Okay. Like that, you can read everything. And now to explore the data. So you want to find out the data structure, right? Structure. What is the structure? For this data. So it tells you, hey, this is an integer, 3, 1, 2, like that. PC class. P class, that is passenger class. Sex is a character, male, female, it comes out like this. Embarkation is yes, Southampton, Cherbourg, like that. Yes, they are a single character variable. Sibling, whether they have sibling or not, parchment, like that. And you know what the PA or parent-child variable is about. It's 0, 1, 2. And if you have a question there, one more time, you can go there. Let me go back. Here it is. Here it is. Okay. So the data set defines family parent-child relationship in this way. Okay. They are accompanied by parent. It says parent. If it is a child, this is the code. Some children travel with nanny. Okay. Those are the three classes. Okay. Now coming back to the model. Let's go over this model. So we just check it out. How many people are there in different classes? 214 are first class, 184 are second class, 491 are third class. And then we can check out the gender, embarkation, how many distributions are, what number of observations are there. Okay, you can do all those things, and that is what is shown here. And then you are ready to And you have to define whenever there is a class variable, these are all nominal variables, right? You have to tell the system, our system, that they are all factors. Okay, that's how you can, you have to do in R. So you are saying that no, passenger class is a factor, gender, sex is a factor, embarkment is a factor. Now you are ready to build the model. And I told you there is a package called NNET. That's really a neural network. But that network also has a function called multinomial model. So this is the formula, and that you just define the model output to be object MOD is multinom. Instead of putting formula, you can put this directly. That's okay. Here, and then data equal to D1. That's your data frame, and then it boom boom boom. It's just after 10 iterations, it converged. Okay, it converges, the likelihood values converge, and the model is built. Okay, and the summary can be found using, so you just get summary mod. He is doing a lot of things on this thing. So in the final case, you got this output. Let's interpret this one. This is our purpose now. Is everybody good so far?
Yes,
Yes,
sir.
sir.
And as I said, this is 3-class model, so you will have 2 collection of parameter estimates. In the case of regular logistic model, you have 2. In this case we have 3-class model, so you have 2 collection of parameter estimates. In the case of usual binary logistic model, you have 2 classes, which means only 1 collection of parameter estimates. Okay, so and it's always in comparison with some left out class. The left out class here is the first class. Left out class here is first class. So this estimate says the relative to the first class that's left out, so it is not here. Relative to the first class, the second class estimates of the parameters are here. The third class estimates of the parameters are here. That's what this is saying. And each of them, each parameters should have standard error estimates. You know why standard error estimates are coming, right, everybody? Anto, you understand why standard errors are coming, right? Because if you repeat the same collection, the same type of sampling in the population, what does that mean in the population? In the case of the Titanic data set, that means if another ship came, it's a theoretical issue, right? If another ship came, there will be a set of differences between the passengers who came in this ship versus another ship. But it didn't happen. That's a separate issue. But had there been another Titanic ship was coming, then there are going to be some differences in the passengers compared to the passengers here. So those differences are mathematically and statistically and theoretically, conceptually evaluated and captured in these standard errors. Am I making sense to you?
Yes, sir.
Very, very important. Many people, have difficulty in interpreting this. That is the reason why standard error happens. And because of that, those standard error happens, because it is happening, you want to make sure that this standard error is not too much compared to the parameter estimates. So that's why we take the ratio. You remember that T ratio? So this divided by this standard error will give us the T value. And that will tell us whether it is significantly different from or not. These estimates are significantly different or not. Same situation here, okay? So anyway, in terms of the model, this is exactly what is we write it. The relative odds of the second class with respect to the first class is this model, and that is coming from here, this first one. Relative odds ratio. The relative odds or logarithm of relative odds with respect to the first class is this one. Everybody see that exactly same, right? Yes?
Yes, sir.
Yes, sir.
So this is relative odds of the third class with respect to the first class. And the first class is the default class that we keep it. We have to compare with one class, and this turns out to be the first class. You can change it also based on some setup, but don't worry about it. Just leave it as it is, whatever the system does for you. Usually it is the first number, okay, for first value, first character class. And so this is again, this is how you write the model. You see this one? intercept is minus 1.564236 minus 0. It's all coming from here. Minus 0.698696 times sex male. That means, male is the variable used. Female is unused. Female is captured in the intercept. Are you with me? Likewise, embark,
Yes,
Queensland. I think it's called Queensland, right? So let me go back. Embarkment is Queenstown. Okay. So if somebody is coming from Queenstown, he will have 1, right? And somebody coming, yes, if somebody is and somebody is coming from Southampton, you will have 0 for this. So it won't have, this won't have the effect of Southampton, but this will have the effect of Southampton. Again, what is the left out category? Cherbourg. Cherbourg is captured in the intercept. Are you with me? So the female is captured in the intercept. Cherbourg is captured in this intercept. And then the sibling, right? If you have the sibling, it is, this is the, weight you have to give for that. If you don't have a sibling, this is 0 value. Are you with me? Parent-child relationship likewise. Okay. So, so in the case of parent-child, you get 1 if they are accompanied by parents. If not, then 0. Okay. Like that, that is for the comparison between a passenger class 2 versus passenger class 1. And you have comparison between passenger class 3 versus passenger class 1 is by these weights. Same interpretation. Okay. Everybody's good? Now, with this, we can obtain the estimated probability for each class as follows. So something called fitted function you have, and this is the model built, right? So you can say round, p hat fitted model, and then you can round it to 2 digits. That's what is happening here. So this is the probability of the, so remember, this is for each of the observation. So given this, probability, which one has the, this is the predicted class 1, passenger class 1, passenger class 2, and passenger class 3. Which has the maximum here? For the first observation, which has the maximum?
Class 3.
That is the class 3. That means you are saying, based on the model, the first observation is predicted to be belonging to class 3. And it may be, correct, it may be actually the same class, or it may not be, it doesn't matter. But it does turn out to be class 3. Do you see this one? This is the original, the predicted is also same. Are you with me? Next.
Yes, sir.
This is only top 6 observations we are checking. Next one. It turns out to be passenger class 1 is the highest one. And the third one is passenger class 3. So this is pretty close. It's going to be a challenge here. Let's see. So second observation is first class. Third observation is third class. Fourth observation is third class. Fifth observation is third class. Sixth observation. All of them. Last 4 observations are third class. Okay. So first class, next to second is first class, the remaining are third class. Let's see whether that is true in the original observation. See, it doesn't have to be exactly right. Predicted can be slightly different. So this turned out to be correct. This turned out to be correct, but here one of them is not incorrect, isn't it? Agree?
Yes, sir.
Yeah, the fourth observation is incorrectly predicted as third class, even though it is first class. Okay. So that is the error. That is the error. But that should not be too much error. That is how you predict the probabilities. That's all I'm trying to say here. Okay. Because once you build the model, you have to apply the model to predict the probabilities. Correct?
Yes, sir.
Not to find out whether the model is good or to apply it in the algorithm, in the system. Okay. So that is the command. You do that. And sometimes you may have a new data, right? So so you can use the new data to predict. So there's a function called predict. Object is model, okay, and the new data is new data. Type is you want type probability or odds. You can do both, okay. So probability is the one, and this is what the probability is, and that's exactly what you saw in 2 digits, but not for a new data, but it's for a regular data. Okay, from the regular data, you are doing that. I mean, the data that you used for the model, you are doing it. So from there, you can get the confusion matrix. Look at this confusion matrix. So because it is a 3-class model, it will be a 3x3 confusion matrix. That's what this one is. Everybody? And it so happened, this model doesn't predict anybody to be for the new data set, whatever the new data set is, okay? The new data set. For the new data set, it does not predict anyone to be in class 2. Okay? So I wonder whether, first of all, what is the actual data? You should think about it. You didn't do it. So the new data, what is the class variable is, right? What is the tabulation for the class variable? So we have to look into it, and something could be wrong. We don't know. So that's what I said. To do the homework, you have a little time. Press the button below to start. Okay. Interesting. Calculate the accuracy for the last confusion table. Create a new model with other covariates to improve the model. So the covariates are only used here: gender, embarkation, sibling, and parchment. Okay, parch, not parchment. Parch. It shouldn't say parch. Parent-child data. Part-ch data. Part-ch variable. So that is how you have to build the model in the case of multinomial, and it gives you certain different, certain interpretations and certain structures behind it in terms of using the multiple class models. Is everybody good? The same thing can be done using what is called discriminant function. Okay, that is another approach one can use discriminant function instead of using the multinomial logic. But I recommend multinomial logic. Is everybody good? I told you what to do also. Is everybody good? Anto and Abhi.
Yes, sir.
Okay. So we will do this again in the lab session, and that's what I wanted to share with you as the last one. There is also one more reference I want to give you. That is what.
Sir, can you share the? Excuse me, sir. Can you share the link in the chat box, sir?
Which one? The presentation deck?
No, sir.
Oh, link.
The one
Okay, okay.
Now.
The ARPA codes she's on.
You're talking about the link, okay.
Yes.
Yeah.
All right, sure. It's coming. All right. So let us see whether another example. Okay, we want to. I want to show you how to do. I have gone through this. This deck is very extensive deck for data analysis. Titanic data analysis. Now, please definitely take a look at that. Okay, it's very useful. It's a real story. I want to now bring to you the idea about count variable. That is Poisson regression. So we want to do Poisson regression. One more example. Which is for count variables. Anto, are you good? Are you with me on in terms of what I'm explaining? Yes.
I'm here.
Inba?
I'm here, sir.
Okay, okay. So this is when you come back, take a 5 minutes break. When you come back, I'll complete the course with this Poisson regression analysis. Okay.
Okay, sir.
All right. Take 5 minutes break. Not much. Maybe okay. 10 minutes break. That's okay because this is the last. I do have is everybody dropped? Okay. I do have I want to give a little bit more references to you about multicollinearity. Okay, multicollinearity. Multicollinearity is the only one, I think. Otherwise, I will mention it in an email for you. A few other things I want you to, I'll give you some reference and read it for yourself. And you can always ask a question, okay? So when you come back, take for 10 minutes break. When you come back, we will go through Poisson regression. With that, we are good. We are done for this particular PA1, and we will start PA2 next month. How about that? Okay, so come back in 10 minutes. Thank you.
Thank you.
Yeah. All right. Welcome back. How is everyone doing? Can you hear me? Hello.
Yes,
Speak
sir.
up. Okay, thank you. So last example, just hang in there, okay, for these instructions. So in the case of, I want to introduce you to more models, but then, within generalized linear models, you remember logistic is, we usually use the link function is equal to logit, right? That is the logistic function, okay? So what we want to do now is that link function, storage, I'm going to show it to you here. The GLM is the model. You remember that for logistic model, okay?
Yes.
And the family is binomial, okay? But now we are going to use what is called Poisson, because sometimes you want to build model for count variable. This is the first time I'm doing that, count variable, 1, 2, 3, 0, like that, okay? So if you have such data, you have to use Poisson regression. And when do you think you will
Can
use
you
that?
repeat, sir? What? Count?
I'm sorry? What is that you're saying?
Can you repeat, sir? Count wave. You were
Count
saying
variable.
something.
Count variable, yes. Okay, the count variable.
Count variable.
Count means 0, 1, 2, 3, like that. Okay, count.
No, sir. I heard like count wave. I didn't hear as count variable.
Yes, count variable, right? That's what we want to use. Then the Poisson regression fits in well. Okay, so here is the link. I want to give you that. It's not so big. Why is it so big? Okay. Okay, it's a smaller link. Let's use this one. That is correct. Okay, this is the link. I'm going to use it for you to explain. And you can read this data set using this command very easily. If you just use this command, pread.csv https stats.idre UCLA. This is from University of California, Los Angeles, site. So let's, I will show you. You can read that, quickly. For example, here it is. I'm just putting it right. P. It's done. Do you see this one? And if I ask for get P, it's going to tell me this is the ID number of awards, and then the program type, and then the math score. Okay, so number of awards is not, it's 0, 1, 2, 3, and limited number of awards will be there. Not too many awards one can get, right? One may get a lot of awards, but that lot cannot be like more than, I don't know, maybe 3 or 4, 5, right? Let's see what it is. So I'm going to do table P dollar num awards, okay? Oh, up to 6 awards. One person got 6 awards. Most of them did not get awards, right? And 49 people got 1 award, like that. This kind of data, which are, small incident data. This is small incident, isn't it? Okay, most of the data, most of the variable value will be here. 0, 1, 2, 3, like that. Okay, small incident data, and it is a count variable. Then if you want to predict this kind of situation, how many awards somebody will get, you have to use Poisson. Do you get, everybody? Do you understand what I'm saying? How many awards somebody will get? It's a count variable. Count. C-O-U-N-T. It's good, everybody?
Yes, sir.
Yes, sir.
Okay, good.
Yes, sir.
So as I said, no, you can just use this command. I have given you the link. You just use this command. It will read. The read.csv has automatically, URL based reading. Okay, URL based reading. It can read. So it reads the data. It's some kind of a data, simulated data. It says simulated data. Okay, or maybe some other data. So the the prog means program type. Is it a general program, academic program, or vocational? And then do they have how much math ability they have. Okay, math is a continuous predictor variable and represents student scores on their math final exam. So what program they are joining, what kind of math score they have, together determines how many awards they are likely to be getting. Is that good, everybody? It's a small problem with only two independent variables, and the count is the number of awards. Is everybody good?
Yes, sir.
Okay. So here is the Ggplot. The commands are here. Ggplot. P aesthetics is number of awards. Fill is the program. Okay. The fill means the program colors. Program colors will be represented here. So most of them are here just 0, right? And then it decreases quickly. It decreases, and there is one person who got 6 hours. 2% or 2% got how many? 2% got 5 awards. Let's see. 3% got 2% got 5 awards, 2% got 4 awards, and then mostly it is 0, 1, 2, 3. Okay, so that kind of rare rare events, low incidence events, rare events, which are count variable. Yes, it's not account variable, it is COUNT. Okay, so that's what we want to model, and Poisson regression, here is some notes, Poisson regression is used, and you can do many other models also. Negative binomial, which means, there is a over dispersion of the case of zero occurrence. Sometimes certain model called zero inflated regression model, and the OLS also. You can do all those things in the GLM, okay? But we are going to do for the data that we just now created, read, we are going to use only what is called the Poisson model, okay, because it represents that. And the command is very simple, summary. It calls the summary of the model created M1 out of this GLM model, generalized linear model, and the family is Poisson. You have to say Poisson. Okay. In the case of logit, it is family is binomial. Okay. So you run this. This is the solution that comes out to be. Okay, so this is just this is the value intercept, and this is academic program, vocational program. So what is left out? General is left out. So that is captured in the intercept. Are you with me, everybody? See, this program is a factor variable, right? 3-class variable: general, academic, and vocational. And the general is captured in the intercept. Okay, and match score. So match score does matter. You see this one? Significantly related to the number of awards. And the academic, if they belong to the academic program rather than vocational or the general, they are more likely to be getting more awards. That's what it says. In fact, you can see this one, very high score, isn't it? This is lower than this one. That's because the unit of measurement is different. This is a class variable. This is a continuous variable. Okay. So, but nonetheless, these two are significant. Vocational programs, they are less likely to get awards, a lot of awards. That's what it says. Is everybody good how I interpreted it? The standard error is there, Z value. Sometimes it's called T value or sometimes it's called Z value. Don't worry about it. In this case, it's called Z value. Okay. Is everybody good so far? So
yes, sir.
Here the important thing, another important thing is, how do I know the goodness of the model? You have to go through this, the star values of the parameters and the AIC. Okay, AIC is Akaike information criteria. Akaike information criterion. Sometimes it's called criterion. That's better actually. Akaike information criterion. So the lower the better. Okay, so the lower the better is, you can see that null model means there is no model at all, and then due to the model you are able to reduce the deviance, residual deviance, residual error this much. Okay, now it is reduced from almost 100 reduced, right? 287. No model at all. Null deviance means no model deviance. Residual deviance means model deviance, what of the model we built. So it has decreased using 3 parameters, 199 observation. Out of that, here we get 196 because we have used 3 parameters here. Okay, actually 3 plus 1, 200 observation. I think it is this 200 observation situation. So it is 3 parameters means 4 observations, 4 subtractions, so it's 196. Here, null model still has one thing, that means intercept. Okay, so you base on the importance of the model based on the goodness of the model based on very different goodness of model. Please note this down, right? Very different goodness of model. We are not talking about AOC. We are not talking about adjusted R-square. We are not talking about variance reduction, all those, but we are talking about reduction deviance, which is the residual error. Okay, which is pretty good here. More importantly, also these two variables are telling us that these two are very significant. So obviously you can trust on this model. Okay. So then you have the same issues in terms of prediction, all those things you want to do, confidence interval and so on. That's what this one is. So lower level confidence interval, upper level confidence interval. That's what this means. So that is calculated to be using this formula here, and the parameters are here. Robust. There is something called robust standard error. So the Poisson regression is affected by the dispersion of the data, or dispersion of data, what is called over dispersion. Okay, I'll just give you some ideas of that. Poisson is Poisson regression, and also negative binomial negative binomial models. All those things are affected by over dispersion in the data. Okay, so there is a method somebody has developed called Cameron and Trivedi. They calculated more robust standard errors, and that's what this package is using. So don't worry about it. Package is giving you the right one. Think like that. And this is probability of z greater than this is the p-value. P-value is this divided by this is the t-value, or z z coordinate. This divided by the estimate divided by the standard error is your z coordinate, and this is the p-value of the z coordinate, right? The probability value of the z coordinate. These are all very small, means very good. So these are all great. You see this one? Okay, this one is not that great, that vocational, that's what it is, because it's a smaller number. Of all these things, not small, I mean, this is the biggest number of all the things if you look at it. This is the biggest number. So vocational programs are not that great. That's what we're saying here. Okay, that's not going to get you a lot of awards. By structure of the data, that's what it turns out to be. Okay. So you can do all the prediction, everything here like before, and also the overall model is another one. Another condition people use is the chi-square, chi-square test. So chi-square test is now gave you the p-value of 0.61. Okay. Yeah, the chi-square value is 0.61. And we are doing what is called the Anova test. This you would have learned it in the
Statistics.
Yes, exactly. Who said that?
Kaushali.
Okay.
Kaushali.
You are going to the stat classes also. You have done the stat class also recently.
Yes, sir. I finished.
You have been attending. You have been super. That's good. But
yes.
How about others? Did everybody got? She said immediately.
They also
Yes, sir. We also attended.
You are getting that idea, right? When I say Anova, right?
Yes, sir.
There is a command,
yes,
so
sir.
you can do that command, with the models. So here it is, M1 is the output. Okay. So one second, let me go and call you that. This one, M1 is the output, right? M1 is the first output, and then M2 is another output. So you are comparing those two models to come to the conclusion, whether it is significantly different or not. So M2 is you are updating it, dropping the prog variable, only math, you are keeping the math. So if you look at the difference, the different turns out to be big. So that means you have to keep the program variable. Am I making sense to you?
Yes, sir.
There are a few different ways to show the goodness of a model, comparative goodness of a model, and so on. Here is the Anova method we use. That's why we have to do these things, in stat. Anova method, so you are comparing the model 1, model 2. Model 1 uses the program type, and model 2 does not use the program type. That's what this minus means. And we are comparing those to Poisson regression model. And here it is the summary that model 1 is number of awards only with math. Model 2 is number of awards with program and math. I think this is switched, unless they redid the model. I don't know. Okay. Yeah, so it is switched. Am I getting across? Gaushali, you probably getting this one. They switched the numbers because the first model was
Yes,
with
sir.
program and math. Second model was without program, so only math. So when we compare that, you can see that the 3-star we get, right? That means very significant. That means you have to use
Very
the program variable in the model. That's what it says. Is everybody good?
Yes, sir.
Okay, super. And then, in order to interpret, you have to do the exponentiation. See, for all general linear model, GLM model, you have to do the exponentiation, okay, to get the to interpret the incremental effect, okay, incremental effect. So here, what we are saying is that we have to use incident rate ratios and their standard errors. Incident rate ratios. That is, incident here is the number of awards. You have to do the ratio calculation. In order to do that, you have to do the exponentiation. Okay. So what we are saying is, you create this exponential of x1 value, exponential x2 value, x3 value, x4 values, and then that is what you are doing here as a exponentiate old estimates, dropping the p-values. So that's what we are doing here. R dot estimate, R dot refers to here. Let's go back to this. Yes, is here, R dot estimate. So R dot estimate is coming from the residual from the model. Okay, so you can do that estimate exponentiation to interpret the coefficient. That's the point here. Okay. So R dot estimate here is R dot. This is what R dot estimate is. Here it is given R dot estimate, and then R, and then when you do the exponentiation, it's called R exponential estimates. Okay. So okay. So in order to do, remember this, in order to do in GLM, for Poisson model, for binomial model, for multinomial model, GLM, we don't use GLM, we use multinom from the NNET. You remember that, okay? From NNET package, we use that. So we have to do the exponentiation to interpret incremental log odds. In order to do the incremental log odds interpretation, you have to do the exponentiation of the parameter values. Okay, is everybody good? That's what we are saying is R exponentiation. So let me go back to that. What are they saying? See, if you look at these things, these are all not exponentiated values. This one I'm talking about, especially this estimates. Okay, so you have to do the exponentiated values. In order to get the exponentiated values, this would 1.08, 1.08. Estimate value here, R estimate. Oh, this is still R estimate. Okay. This is still R estimate. So in order to get the relative logarithm of the odds, because logarithm of the odds is equal to the linear function. Okay. So if you want the logarithm of the odds from the original model, then you have to do the exponentiation. That's what we are saying here. You will see that in the previous example also. I gave you the reference. You can check it. You can check it out. So here, and then you can do a little bit of chi-square model here. You are doing that for deviance also. You can do it chi-square model for the deviance, or you can do the chi-square model for the overall prediction of the values. Okay. So I went through this one already, right? Oh yeah, I went through that one. This is the delta estimates, the change, additional changes. Oh, and then you can find out the fitted values. Okay, of course, predict function you can always use. So in this case, the response, all right? And remember, we are talking about the number of awards case, right? So this is the math for the first 3 observations. The math value is this much. The program is general, academic, vocational. So you are keeping the math value same, because that's how you can interpret it. Math value same, and then ranging the changes. You are bringing the class differences, general versus academic versus vocational, and then you are trying to. This is the kind of sample values, right? Sample values. That is what is created here, and for that you are kind of predicting using the model M1, and the value data set is this one, S1, and we want the type to be response, not probabilities. Okay, response means in this case number of awards, right? So what is the number of probability of getting the award 1? For this case, general, it is 0.21, and for this case, academic case, it is 0.629. For the vocational case, 0.30, and their standard errors are estimated like this. So the predicted number of events, because not probabilities here, it is the class, predicted number of events for level 1. For level 1 is 0.21, holding math at its mean value. This is the mean value held constant at the mean value. Am I making sense to you? See, in order to interpret the model, we have to use some special approach, for GLM, which is generalized linear model, which is an exponential family of distributions. Please write it down. GLM is about exponential family of distributions. Poisson is an exponential family. Even normal regression is an exponential family, okay? But it extends the algorithm into a very sophisticated modeling approach where you can use normal distributions, you can use logistic distribution, you can use Poisson distribution, you can use exponential negative binomial distribution, you can use a gamma distribution, all kinds of distribution you can use. But then you have to do, it's a complex, in terms of interpretation. So you have to do, set the value. When you have multiple variables, you have to set the value of other variables at some constant value, typically the mean value, and then vary the variable that you want to interpret, its effect. The variable we want to interpret, here is the program type. So we keep the math value to be at some value, typically the mean value. It turns out to be this is the mean value. So that's why we are defining this mean to be set value here for the new data frame S1. Am I getting across to you, Abhi and Anto?
Yes.
Super.
Yes, sir.
Because a little bit of
Yes,
complexity is there, okay? A little bit of complexity is there. But, once you go through this a few times, you will know. So you have to think about it that whenever you use generalized linear model, which is the exponential family of distributions of models, which means we extended all the things to more sophisticated situation, okay? You can do all kinds of distributional model, very large collection of distribution model. And there you have to set, when you are interpreting the one variable, as one variable changes, you have to keep other variables constant. What value? Mean value if it is a continuous variable, okay? The math is continuous variable. Otherwise, you can keep, some other state, the qualitative state. Suppose this is, socioeconomic status, high, low. Then you keep everything high, and then you range here, or low, you range here. Okay, change here. Then you will be able to interpret the what is that one we are talking about here? The same thing here. That is, we see the predicted number of events for level 1 is 0.21 only. That's what it says. For general program category, for the predicted number of awards, the predicted number of, in this case awards, right? Predicted number of awards is 0.62, and for this, for the vocational, it is 0.30. Okay, remember this is not probabilities. I just want to mention again. Okay. So that is the kind of interpretation, and you have a predict function. You can use it for the data model. For the model, if you do just this, it is using the model data, so it will predict that. And here is the predicted function. As a Ggplot, you can see most of the reds are here, so red is below here. Reds and blues are mixed here. I'm sorry, blues are mixed from here to here, so blue is here, and then almost all greens are, you can see separated out here, right? So the green is picking up from here all the way to here it is mixed up, all the green, blue, everything. So it's all here together. But as as math score increases, more and more greens are happening here. So accordingly, this is the graph. This is the visual way of looking at the results. So with that, we kind of covered. Really, it depends on how you received it and how much you are able to hold it with you. And of course, we still have 15 hours of lab hours, so don't worry. We will repeat all these things based on how much you are able to retain. You got a phenomenal, amount of knowledge here. Seriously, I'm telling. It depends on both the curriculum and the student. So it still depends on you. But don't worry, but you still have approximately 15 hours to go through. So we will repeat many of these examples. That's the idea. How is it looking like? I'm sorry? Can you repeat?
No,
Hello?
it's a bit confusing, sir.
Which is confusing?
No, everything in one class. So
well, what can we? So the thing is, remember, I'm not expecting that you will remember everything, but at least you should know what kind of reference I have to look at it, how do I interpret it, why it is different, all those things. The broad strategies, you should have that very clearly understood. For example,
yes, sir.
Poisson, you don't do for Poisson for every model. When it's a count variable, you do that. And it should be a rare event. There are lots of data structure, data sets where you have such situations. Okay? So, for example, if there are, if a manager is going to predict whether the shopping lines or which shopping lines are going to get more difficulties in terms of handling the situation, quickly as the people who are going in for checking out at the counter. So you can see that the automated system can say that look, this side is because we have this weekend, we have a sale. There are visitors coming to the town, so we have to put more resources. So those kinds of things can be a Poisson regression model, for example. Are you with me? So the rare event problems are Poisson regression. If it is a classification model, yes or no, it's a binomial regression, binomial logistic model. If it's a multiple classes, it's a multinomial logistic regression model. And otherwise, if it is a continuous dependent variable, it's a regression model, linear regression model. So you have to have the broad strategies in you and the knowledge I have given you, recordings I have given you, examples I have given you, the lab hours that you will go through. These should give you the strength to apply these things in your real life, in your job. Confusions are, I'm not expecting zero confusions because you
no, it's not like that. It's not like that, sir.
Go ahead.
No, actually, I could understand everything, but everything in one class, so that is a bit confusing. Like, when do we use Poisson and binomial, and how we categorize which should be the constant variable, like intercept. So that's and all I should go through once again.
Of course, you will go through one more time this one in the practical period,
yes.
the lab period. Also, remember, only by practice your brain gets accustomed. One thing I'm expecting from you folks is that as students, I'm expecting that you are going to be committed to this science. It's not just to get your promotion. Maybe some people do that, but it will only come up to that level. And after 3 years, if you are just doing this course, not you, I'm saying, for example, people do that. With a diploma in data science, they get more recognized, right, in the organization, especially where there is a demand, right? So they will get a promotion, they'll get an increment and so on. But if you don't use it, what is the use, right? It will go away. It is nothing to do with this science, any science. So you all have to commit to data science if you want to become, a smart person with the data science commitment. And, it has a huge future. or machine learning. You want to call it instead of data science, you want to call it machine learning, that's okay. You want to call it as AI, it's okay. But the point is you have to commit to that, because every day you have to do exercise, mental exercise and physical exercise. What you don't use, you lose. So I am hoping,
Exactly,
yeah, please. I'm hoping that I'm able to talk to you so much only because I do this every day. I mean, really, I don't do it every day, but that point is because I have other works also to do, manage the organization, teach, some other subject in another university. I do all this, right? But the thing is, still, I do think about it, because when I teach these things with you, I do think about it. But that commitment, if you have it, you will become a master. I have no doubt. I can tell you, even people who do PhD, they have to review this. Review. Think about it. Do work. But it is fun. If you think it is fun, you like to do it, you are committed, it will stay with you. But like anything, it doesn't matter whatever it is. Like anything, if you don't use it, you will lose it. I'm hoping you will all use it regularly, become a data scientist, and it's a very rewarding position. Become a data scientist and use it regularly, then you'll be fine. And another thing is, you become a teacher. Best way to do this exercise regularly is you become a teacher, so you teach others. Out of commitment, it will get retained in your brain. So it's every moment the world with its gravity, with its rotation, it's going away. Unless you are controlling the entropy. You know what I'm saying? Entropy. Anto, are you with me?
Yes, sir.
It's called.
I am, sir.
It is called the entropy. There are a lot more forces that is making you to expend your energy out in a chaotic way, but you have to do it. The discipline and commitment is what is bringing you that energy back to your focus, reduce the entropy. So your duty is to reduce the entropy. Of course, you don't have to do this one. You can do some other science, but whatever the science you do, you have to repeat that, more focused. Be the master, be the expert that you want to be. So you have to. This is like a treasure. Sorry, Garin, what did you say?
No, I just told we'll do that, sir.
Very good. Very good. Thank you so much. You still have 15 hours, so it's coming. I'm going to speak with the Supriya. She is very good. She has been with me for quite a number of years. And she will go through this example.
So, sir, I have a doubt. Sir, can you please scroll down?
Up or down?
Last, sir, last.
Is it okay?
No, sir, come down, sir. The last point we have summary and
This one?
no, sir, last. Come to the last. Last.
Last class?
No, not last class, sir. Last. I have some doubt in the P. The last 4 lines of the points. Not in this.
Okay,
in the PDF, sir. The link.
So in the link,
Poisson regression. Yeah, there's some point.
are you talking about this?
Not, sir.
No, let me walk you.
Can you please come?
This is the Poisson regression.
Yes, sir. Poisson regression. The last we will be finding out which is the best fit and all. There is a point somewhere I didn't understand it.
Best model?
Can you please scroll down? Yeah, can you please scroll down, sir? The last.
Best model or a comparison of best model? Is that what you're saying? This one is the comparison of best model.
No, you have a title called Things to Consider, sir.
Oh, that's the interpretation. You're talking about interpretation?
Yes.
Things to consider.
Yes, sir.
Interpretation.
Yeah.
Okay. You can,
Yes,
you
yes.
know, basically, it's, so this is something about, so the thing is, there is something called a dispersion, right? There's over dispersion that happens in the, that's a theoretical issue that it can happen, over dispersion can happen. That means too much variance can happen in the data set. Okay. Under that condition, there are some complications. That's what he is talking about. So for now, you just hold on to this. Don't worry about this one. This is
Yes, sir. I have a doubt that R square, pseudo R square.
Yeah, but we don't.
The
Wait. 1 second. Pseudo R square. Yeah. So that is coming under the things to consider, right? So many different measures of pseudo R square exist. Pseudo R square means it is similar to R square, but it's not R square, right? Because you cannot do R square here. So you try to do using, likelihood values as if it is R square and so on. So they all attempt to provide information similar to R square in OLS regression, even though none of them can be interpreted exactly as R square as in OLS. That's what I'm trying to tell you. Okay, so don't spend too much about all these things. Right now, you get the higher level, you can go deeper and deeper slowly. Okay, so things to consider is good. It's important. You can use it, but it is only going to give more uncertainty in your understanding and in your interpretation. Okay,
sir.
so just stay put, and this is what you need to be retaining it in your brain when you strategize your communications. Okay.
Yes.
Are you with me? Yeah. So this is important, but right now you have more bigger things here. Are you clear about all these things? Why you are doing what you are doing, how you are using it? That much first. That's all I cover. Okay. And then this one, okay, there are issues that you have to think about all these things. Yeah, of course we know. Actually, I made this point. Don't use pseudo R square, if you remember. For the logistic regression also, I said don't use that. You remember that?
Yes, sir.
Yeah, it's the same situation. People write something doesn't mean that that is the best standard in communication. I said don't use it, and they're saying there are different things. You have to be careful. This and that. I'm saying don't go there. That's my communication to you. See, this is where I come important to you as a teacher. In the internet as well as anywhere, even in teaching also, in general teaching, I would say there are always a lot of unknown areas. People have different levels of confusions there, or different levels of deeper interpretations, and you are not there yet. Are you with me?
Yes, sir.
That you stay there. You stay there.
Yes, sir.
So follow the guidelines. Just follow the guidelines. Right now, my purpose is to make sure that you know Poisson regression, you know when to use it. You heard it 2-3 times, but it will fly away. We will keep telling that when to use it and how do we interpret all the parameters in the multinomial case, Poisson regression case, right? All these things are important for you. If you do that much, you are good. Use chi-square values to, and also the star values for the z, p values, star values for the p values. Use that. That's the end of the story. Don't labor too much. You will solve the problem 90% of the time. That 10% of the time will create 90% of the answer. Am I making sense to you?
Yes.
10% of the time, which you don't know fully, will take you to the place where there is 90% of confusion. We don't want that. Agree?
Yes.
Yes. Anto, am I making sense to you?
Yes, sir.
Sir, I have a doubt. Like in Poisson distribution, you are talking about ACI, right?
AIC. AIC.
Okay, sorry, AIC. So from that, how will be calculating the values? Like what the value we interpret from that? What the conclusion we'll be getting from that?
I like even compared to AIC. I actually did thesis in multinomial model selection. Okay. Instead of AIC,
Okay.
do the chi-square test I showed.
Okay, sir.
Just stop there. People will give you. They will ask you, "Oh no, why didn't you use AIC?" You say that no, I solved the problem using chi-square test. I mean, making sense to you?
Okay, yes, sir.
You stay there. You stay there. You can use AIC also. I don't know. It's just the way it is printout is coming. It's not very clear and appealing. The way it is printout is coming. There are some additional work here. So the incremental AIC, how it is decreasing, you have to see that. They don't give that. See, as the variable you increase, like in the case of the test error and the training error, the incremental AIC will decrease. The more it decreases, the better the model.
Okay.
We are just saying, after given the model, it shows you the AIC. It's not stepwise, it is changing and then telling you what is the best model. So now that brings up, another concept I wanted to share with you. So in the case of there is a stepwise model selection method. I do want to speak with you about that also. Model selection, one second. So, so regression also, they have stepwise model selection, different types of stepwise model selection. That is the way to go. Not just not just variable. Okay, it's called variable selection. There you go. So I would like you to go into this. There's a package called variable selection. Okay, so that tells you there are two packages: variable selection under OLS RR, and then another one is feature selection with the caret R package. Okay, so that tells you stepwise. So here it is. This is what you need to do. OLS step both AIC, for example, right? In this case, OLS step AIC, but AIC is more useful for non-OLS. That means complex models, not for ordinary linear regression. Okay, AIC is valuable not just for OLS model, ordinary regression, but it's useful for complex regressions, which is like generalized linear models. Okay, so there is what is called the step forward, step backward, best subset. All these things are possible to select models. So if you do that step by step, it is changing the AIC values. Then it makes sense. Are you with me? Are you with me?
Yes, sir.
Okay. So what is the solution? Solution is follow what I said so far. Maybe in the lab session we will show you an example of how to use the stepwise methods for variable selection, for finalizing the model. Your testing and training error is a concept general concept for machine learning approach when we have more and more complex models. It is competing with stepwise approach for regression, stepwise approach for logistic regression or linear regression. Okay. At that time, if you want to use AIC, that's okay. AIC is one method. Are you with me?
Yes, sir.
You're not confident?
Not like that, sir.
Anto.
Yes, sir.
Are you okay? Are you confident what I'm talking to you?
Yes, sir. No.
So there is a stepwise method you can use. There you can use stepwise how the variables come in and go out. There is a selection procedure. When you have 20 variable, 30 variable, you want to use that method. Maybe we will show it to you in the lab time. That's my point. You also see AIC will change, and accordingly you can interpret it. Okay, well, somebody wants to say something? Gaushali or Abhi? Somebody wants
Nothing, sir. I just want to,
No, sir.
yeah. It is just an AIC, it's just a statistical score. How we finding the score? Okay. So we have an
how to build a good model. It's a goodness of fit. It's a goodness of fit.
Yeah.
Instead of pseudo R square, it is better to use AIC. It's not pseudo. No, pseudo R square, don't use it. Sir, என்ன சார் எல்லாரும் போட்டு இருக்காங்க நீங்க சொல்றீங்க, is that a question? It's useless.
No, sir. I'm just explaining her. It is also one of the statistical score. So we get as a result. It's also one of the statistical.
That is correct. It's one of the things, but you can solve the problem. If you use AIC correctly, you can solve the problem under some conditions. I'm suggesting you also have other methods. That's where the stepwise method comes in. You can solve the problem there. There are many other ways, but I have given you minimal collection of tools for you to succeed maximal situations. Am I making sense to you?
Yes, sir.
You have to continue to be exposing yourself. Be ready to receive. Whenever you see somewhere, or you are working in your company project, at that time you realize, no, why don't I try AIC? No, you work it out. You see, oh, okay, this one, because you know so many things. You know how to do the right search, even in internet. Right search. Am I making sense? Gaushali?
Yes.
Yes.
Anto, Abhi?
Yes, sir.
Okay. You're okay now? You feel confident?
Yes, sir.
Okay. All right. So with that, we conclude Pair 1. You might ask some question when you go into a job. You might end up asking a question. That's where we have the community. Somebody will answer that if they know it. Otherwise, I'll answer it in the community. You're all part of the community. Am I connecting with you on that
Yes,
one?
sir. Yes, sir.
There are people in the WhatsApp group. We got all our previous students who want to be connected. It's voluntary, So, for example, somebody asked me a question. I was teaching at Loyola College 6 years back. I taught one course maybe, or some sessions, something. I started the executive data science program, executive diploma in data science, something like that. Okay, I don't even remember the title now. I started the program in Loyola College. I taught one term, okay, because I just want to bring this education to India. Loyola was my alma mater, so I was very happy to do that. One student asked me a question last month in text analytics. I did not teach text analytics. In text analytics, she asked me, how do I do this? I said, no, you have to do this. She said, thank you. So I keep up with my students. If you have interest, you can do that. And, I try to help. And not that I can promise every time I'll be there. Today, I know, even with other busy work, I do that. Maybe I may not be able to do that in future, long time in future, not next year. I'm saying long time, maybe 5 years from now. I may be too busy, or, I will have enough people to respond to you other than myself. It's possible. But the point is, you have to be connected with the group, with the people who are experts in your field. Am I making sense to you, Anto and Abhi? Am I making sense to
Yes,
you?
sir.
Yes, sir.
Okay. So be confident. You're all good. You have enough to think about, enough to practice, just with one course. But we are going to give you another 4 more courses, right? No. Unsupervised algorithms, machine learning, and then Spark Analytics. That's more about big data analytics, systems based, huge systems, cluster computing, and so on. Am I expecting you to become an expert? No. Am I expecting you to be a good student? Absolutely yes. What do you mean by good student? Can somebody tell me what is meant by being a good student? Good practitioner. Talk to me. And Abhi.
Yes,
Wanna
so
delete.
we are committed to study, sir, and we are a good student, sir.
You have perhaps lifetime of training, education, continue to be curious. Nothing beyond that. The moment you are curious, your brain will not keep you sleeping. It knows how to get the answer. It's a super thing, no? The honest brain, sincere brain, once you have the question in the brain and you are honest about it, it makes you a better person actually. And it will not stop. It will safely land you like a parachute. Once it opens up, it will safely land you. It will safely land you.
So may I take leave?
Huh?
I have an assignment to submit, sir. May I leave, sir?
Go ahead. Have
If-
fun. Thank you very much. Bye. I'll see you in PA 2. That's supervision. Next month.
Okay, sir.
Thank you. Bye-bye. Go,
Sure,
Shelby.
sir. Take care. Bye. Thank you,
Thank
sir.
you very much, Abhi. Take care. Bye.
Good day to you.
Thank you, sir.
Good night, everybody. Go, Shelby. Thanks. Bye-bye.
Have a nice day, sir. Thank you, sir.